Good morning, students. Before class we have studied about the thermal expansion, thermal energy. Till thermal energy we have studied. Last class we have studied about real and apparent expansion of a liquid and ideal gas equation and gas laws, Charles law, Boyle's law and Avogadro law. Today we are going to see the small part which we left not seen in the lesson. First one, characteristic features of heat energy transfer. Heat always flows from has water and current from a higher temperature to a lower temperature. Heat, water and electricity will always flow from higher level to lower level. The mass of a system is not altered when it is heated or cold. Even when ice cube has some mass and it is turned into water, it is also having a mass. The mass won't be altered. Already in weight and mass differentiation, we have seen that mass is unaltered. It won't be changed. Weight can be varied, depends upon the gravity of the place. For any change of heat, the heat gained by the cold system is equal to the heat lost by the hot system. Heat gained is equal to heat lost. This is in thermal equilibrium we have studied. Isn't it? If you keep a hot cup of coffee in a table, after some time it will comes down its temperature because it exchanges its temperature with the surroundings. What is the heat lost in the cup of coffee is equal to the heat gain in the surroundings. It is a thermal equilibrium. These 3 points I said on that class. And other units of calorie. What is the unit of heat energy? Heat energy is always measured in whatever be the energy, it is measured in joules. Heat, one more unit for heat is calorie and kilocalorie, the amount of heat. 1 calorie, these two are 2 mark important, 2 mark answers, short answers, these two definitions. 1 calorie is defined as the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. 1 gram of water should be heated and the temperature should be raised to 1 degree Celsius by supplying the amount of heat energy. Is defined as 1 calorie. Once again I am saying kilocalorie. 1 kilocalorie is defined as the same amount of heat energy is required. How much amount of heat energy is required? To raise the 1 kilogram of water temperature to 1 degree Celsius is called as. Already the water will be in 30 degree Celsius or something else. The amount of heat you are given should make the water temperature should rise to 1 degree Celsius is called as kilocalorie. These are important 2 marks. So you can mark the answer if you are having a book on your hands. Okay. This is the answer for defined calorie and this is the answer for defined kilocalorie. Okay. Then we will see the effect of heat energy. What is the effect of heat energy? By giving in heat, what are all the effects you will see? Temperature of the substance rises. The substance may change its state from solid to liquid or from liquid to gas. For this you must always take an example. Best example, ice cube to water, water to vapor. The substance will expand when heated. Whatever the solid substance or a liquid substance. In real and apparent expansion, we saw that the liquid in the down bottom flask expands. Isn't it? So, the substance will expand. So, whenever you are supplying heat to an substance, the temperature of the substance will be rising, 1, and the substance may change its form from solid to liquid or liquid to gas. So the state of change will be occurred and the substance will expand. Either it is in solid or in liquid, the substance will expand by absorbing the heat energy. The rising temperature is proportional to the amount of heat energy supplied. How much you are given the amount of heat, that much it will shows the difference either in the expansion or in the change of state. For example, in apparent change, we saw only the expansion, not the change of state. If it goes on heating, what the water will do? Water will comes to the boiling point, then it will changes into a vapor state. So it will depends upon the temperature what you are giving, whether it is rise in temperature or expanding or change the state. About the rise in temperature and change in state, you have studied the previous classes. In the following section, we shall discuss about the expansion of substance due to heat. What is expansion? By giving the amount of heat energy, the substance will expands. That is thermal. Using a thermal energy, it will expand, so it is called as thermal expansion. The change in dimension due to rise in temperature is called as thermal expansion. You can note the definition here. You can note the definition. See this change in dimension. The change in the dimension due to rise in temperature is called as thermal expansion. What is thermal expansion? Change in dimension due to rise in temperature is called as thermal expansion. That is, expansion of liquid can seen when the thermometer is placed in a warm water. For example, for fever checking, we are using a thermal expansion using a thermometer. When a thermometer is placed in a warm water, you can able to see the expansion of mercury, that is liquid, inside the thermometer. What are all the types of expansion? 3 types of expansions are there: linear expansion, superficial expansion, and cubical expansion. When a solid is heated, the atoms gain energy, heat energy, and started vibrating vigorously, randomly. This results in the expansion of the solid. For a given change in temperature, the extent of expansion is smaller in solid than in liquids and gases. This is due to the rigid nature of solids. 3 types of thermal expansion is there. First, we had studied what is a thermal expansion. Change in temperature. See, change in dimension due to the rise in temperature is called as thermal expansion. Change in dimension due to the rise in temperature is called as thermal expansion. What are the 3 types of thermal expansion? Linear expansion, superficial expansion, and cubical expansion. What do you mean by linear? Linear means line. A thin rod will expand due to heating effect. The length of the rod will be increased because of the given temperature is called as linear expansion. Or an longitudinal expansion. When a body is heated or cooled, the length of the body changes due to the change in temperature. The length of the body changes due to the change in temperature. This expansion is said to be linear expansion. Coefficient of linear expansion. What is coefficient of linear expansion? How much the length will be expand, the rod will be expand. That depends upon the temperature, how much heat you are giving the temperature, and depends upon the length also. If you are giving a very small length, you can expand the smallest expansion. If you are heating a very longest rod, you can expect some more expansion than the shorter one. So the ratio of increase in length, depends upon the rise in temperature to its unit length is called as coefficient of linear expansion. The SI unit of expansion, linear expansion, is Kelvin. The value of coefficient of linear expansion is del L by L0 is equal to alpha L into del T. Del T, change in temperature. Del L, change in length. Final length minus original length. Then alpha is the coefficient of linear expansion. In the same way, you can say it for Areal expansion. Superficial expansion is otherwise called as areal expansion. Cubical expansion is otherwise called as volume expansion. You just alter the formula and try to say the areal expansion. Areal means instead of L you can use A. Del A by A naught is equal to alpha A or S. You can use alpha A or S into del T. Del A change in area, A naught original area, del T change in temperature, alpha A change in coefficient of areal expansion or superficial expansion. The same way, if there is an increase in the area of a solid due to heating, then the expansion is called as areal or superficial expansion. If there is an increase in volume of a solid due to heating, it is called as volume expansion. Coefficient, the ratio of increase in area per unit area per degree rise in temperature. Per degree rise in temperature, 2 unit area is called as coefficient of superficial expansion. In the same way, for volume, how will you say? The ratio of increase in volume of the body per degree rise in temperature to its unit volume is called as coefficient of superficial expansion. So once you thorough with the linear expansion, you can able to write superficial and volume expansion. The formula also del A by A naught is equal to alpha A into del T. You know what is del A? Change in area, A naught original area, and del T change in temperature, and alpha A coefficient of superficial expansion. You want me to explain the cubical? Increase in volume due to heating, then the expansion is cubical expansion. Coefficient, then here given some metals and their coefficient. Coefficient will be constant for the metals aluminium, brass, glass, water and mercury. Expansion of liquids we already seen. Real expansion, apparent expansion, isn't it? That's all. Up to this the lesson is over. What we had seen in this lesson today: characteristic of features of heat energy, then other units of energy, calorie and kilocalorie, effect of heat energy, expansion of substance. In this thermal expansion, 3 types of expansion: linear, superficial and cubical expansion, and their coefficient of expansion. Up to this the lesson got over. Third lesson is completed. Already we had seen these things, expansion and loss. So your third lesson is over. Thank you.